Hey guys, today we're going to talk about how to calculate area and perimeter, and you're going to be using two methods that we used last week before spring break, which are the distance formula and the Pythagorean theorem. So just to recall, the Pythagorean theorem and the distance formula are two ways that we can calculate the length of a side or the length or distance between 2 points. So if you want to find the diagonal distance between 2 points, you can either use the Pythagorean theorem or you can use the distance formula where you're going to identify an x1, y1, which will be one of the points, and an x2, y2, which will be the second point. And you're going to plug that into the distance formula to find the length. Both methods can be used to find the length between 2 points or the length of a side of a certain shape, whether that's a quadrilateral or a triangle. You can find the length of a side. Okay, and what we're going to be doing with the distance formula and the Pythagorean theorem is we're going to be finding the perimeter and the area. So the perimeter is the length of all the sides added together. So a lot of the shapes that we see with quadrilaterals, such as squares or rhombuses or parallelograms, they're going to have sides that have congruent lengths. For example, this rectangle has a congruent length between the opposite sides. So when we're finding the perimeter, what we want to do is we want to add up all of the total sides. So even if those sides are the same, I'm still going to add up each of the sides. And then that is going to be a singular unit. So whether I'm talking about inches, feet, miles, I'm going to be measuring just in singular feet. And you want to make sure that you always include units. Okay, and then for the area is the amount of space inside of the shape. So if we're looking at this square right here, there are 9 blocks within the square. So the area of this square is 9. But what happens if I look at, say, a triangle, and the triangle cuts through squares, so you have some kind of oddly shaped triangles within there to calculate the area of. So we're going to be using different formulas to calculate the area. So for a rectangle, the area is the base times the height. For a parallelogram, area again, base times height. Now the height is the vertical drop or the altitude of the parallelogram because a parallelogram has a slanted side, so we want the straight vertical side to find the height. A triangle is 1/2 the base times the height, again finding that vertical drop. And then for a trapezoid, we have 1/2 times the addition of both of the bases of the trapezoid times the height. Now we're not going to be looking at trapezoids too much, but you will have to find rectangles, parallelograms, and triangles. Now the units for area, if we're talking about feet, the units would be feet squared. If we're talking about inches, it would be inches squared. So anytime you're calculating area, it's the squared units. Okay, so in this example, it wants us to find the perimeter and the area of the parallelogram. So I went ahead and I copied over the picture for the area of a parallelogram, so it's the base times the height. So we're going to let each unit represent 1 centimeter. And the reason that I put that there is because that's going to help us when we're determining what the units are. So anytime you have a straight vertical or straight horizontal side like AB, you can just go ahead and you can count the distance between each square. So you can just count the distances. So 1, 2, 3, and you're going to keep counting all the way until you find that this length is 12. So side AB is 12 centimeters. Okay, and AB is congruent to DC, and we know that because parallelograms have congruent sides when they're opposites, so opposite congruent sides. So that means that DC is also 12, which you could verify again by counting the blocks. So DC is also 12 centimeters. Now things get a little ugly when we have the slant going on. So we want to find the length between AD. And you can either choose to do the distance formula or the Pythagorean theorem. So if you were doing the Pythagorean theorem, you would create your drop down, your vertical, and you'd create your horizontal side so that you have your A and your B, and you're ultimately solving for C. But for me, because they gave us the points already, they gave us B, the point for BC, and they gave us the point for A and D, I'm going to go ahead and use the distance formula just because I think it's a little bit easier to plug in. So for me, finding the points of BC, B is 10, 3, and C is 5, negative 4. So I'm going to plug that into the distance formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared. And when I'm choosing my x1 and y1, I like to identify what those points are before I start so I don't get confused. So I'm going to let B is going to be my x2, y2, and that doesn't matter which one you choose to be that. I just thought because 10 is bigger than 5, it's easier to choose that one when I'm subtracting. So that means that C is going to be x1, y1. Okay, and then from here, I'm going to just substitute those values in. So x2 is 10 minus 5 squared plus y2 is 3 minus, well, here's the big deal, it's a negative 4, so I'm going to go ahead and put that negative 4 in parentheses. I want to minus the negative 4, subtract the negative 4 squared. So that will give me 5 squared, and then this 3 minus a negative 4, that ends up being 3 plus 4. So the minus and the minus become a plus. So that means I'll have plus 7 squared, and that's going to give me 25 plus 49, which is equal to the square root of 74. And I know that's not a perfect square, so I'm going to approximate that answer to be 8.6. Okay, so that means that AC and BC, because opposite sides of parallelograms are congruent, are both going to be 8.6. If they weren't congruent, you would do the distance formula again. So that can be kind of annoying, but you're going to keep doing the distance formula. And you can verify that AD is also congruent if you were to plug in x1, y1, x2, y2 using A and D as your points instead. So that means side BC is 8.6, side AD is 8.6. And the units on those are both centimeters. Okay, to find the perimeter, you're going to add up each of the sides. So you're going to add 12 plus 12 plus 8.6 plus 8.6, and that's going to give me a perimeter of 41.2 centimeters. Okay, for the area, again, I want the base, which we know the base is 12, and I want the vertical height. So that means that I'm going to take this and I'm going to just drop a vertical, and I'm going to count to find the height. So 1, 2, 3, 4, 5, 6, 7. So that height is 7. So that means that the area is 12 times 7, which is equal to 84. And here's the kicker, centimeters squared. Okay, so a parallelogram is similar to a rectangle, and you're just doing length times width, or base times height. But here we have little pieces, triangles. If I were to take this triangle right here, and I were to replace it over here, notice that you would have, if you can see it, you would have a rectangle. So that's why it's just base times height. So here would be my rectangle that I'm talking about. Okay, for this example, we're no longer looking at a parallelogram, we're looking at a triangle. And specifically, it's a right triangle because I've got a vertical and a horizontal, so those two are meeting at 90 degrees. So I've got a right triangle. So what I'm going to do is I'm going to, again, just like I did for the parallelogram, sorry about that, I'm going to find each of the side lengths because when I'm finding the perimeter, I have to find all the side lengths. So the easiest ones to find is the ones that I can count. So if I count the blocks and I count the distance, I should find that this has a length of 7. And I'm going to also do that for the ones that I can count. So I can count these, and I'm going to find that that guy has a length of 8. So EF is 7. And let's just say that this is measured in inches, because I want to think about units continuously. So FG is measured at 8 inches. Okay, now EG is again a diagonal, so you cannot just count it. You either have to do the distance formula or the Pythagorean theorem. But think to yourself, when do you usually use the Pythagorean theorem? And you usually use it when you're dealing with right triangles. So if I already have a triangle, specifically a right triangle, I'm going to go ahead and instead of using the distance formula this time, I think it's easier just to use the Pythagorean theorem. So ultimately, I'm trying to find the length of the diagonal, and I'm going to call that length C. And that's just because I know the Pythagorean theorem is a squared plus b squared equals c squared. It doesn't matter which one you have as A and B, but it does matter which one is C, and C is always across from the 90-degree angle. So that means, let's just say 7 is A, and 8 is b. And I can go ahead and substitute those values in. So 7 squared plus 8 squared is equal to c squared, which is what I'm trying to solve for. And what I'm going to do is I've got 49 plus 64 equals c squared. 113 equals c squared. You're not done yet. This is not the length. It doesn't really make sense either because the blocks aren't, there's not 113 blocks obviously within this length. So I do have to find the square root. I saw a lot of people make that error on the quiz. Make sure that you're doing square roots at the end, whether you're doing the Pythagorean theorem or the distance formula. So that means that C is going to be 10.6 inches. And I always round to 1 decimal place. I round to the nearest tenth just because I want to keep it clean. So 10.6. Okay, when I'm finding the perimeter, I'm going to add up all of the side lengths. And I already have all the side lengths added up, or I already have all the side lengths given to me. So I'm just going to go 7 plus 8 plus 10.6. That's going to end up being 25.6 inches, singular units. Now for the area is 1/2 the base times the height. Now the area of the triangle, especially when it's like this, is like one of the easiest things that you can do because the base is the bottom, which is my horizontal distance, and the height is this vertical distance, which both of those we were just able to count. So that means it's going to be 1/2 times 8 times 7. So you didn't even need the diagonal distance for the area, you just needed the counting distance. And that means that we have 28 inches squared. So your perimeter, 25.6 inches, and your area is 28 inches. Okay, the last example I want to go over is what is the area and the perimeter of a square DEFG if the coordinates of D is 0, 0. So I'm going to go ahead and plot that point D, and E is 3, 0. So here, you don't necessarily have a square, but the fact that you know the properties of a square should help you out here. So what are some of the things we know about a square? We know that there's 4 right angles. We know that all the sides are congruent. So all the sides of a square, so all 4 sides are congruent. That means that if I have a square of any length, let's just say my length is x, that means each side is also going to be x. So in this case, it gave me one of the sides. It gave me DE, but it didn't give me anything else. But DE is all I need because what's the length of DE? 1, 2, 3. So the length is 3. If I were to go ahead and draw the remaining part of the square, it doesn't matter really how, if I draw it up in the first quadrant or down in the fourth quadrant, I'm just going to draw it up. I'm going to go a distance of 3, a distance of 3, a distance of 3, because all of the distances of my square have to be the same. So no matter what F and G are, I know that F is 3 units away from E, G is 3 units away from F, and F is 3 units away from D, or G is 3 units away from D, so G, F. Okay, so if I'm trying to find the perimeter, you add up all the side lengths. So all the side lengths are 3, so 3 plus 3 plus 3 plus 3. That means that my perimeter is 12. Doesn't specify units, so I'm literally just going to write units. 12 units. And then for area, the area of a square is just length times width, or base times height. So here, if my base is 3, my height's 3, again, because all 4 sides of a square are congruent. So 3 times 3, which is 9 units squared.